This is Ultimate Infrared project for Arduino. We're going to learn how to detect any remote using Arduino, so we can take action when you press a key to do something. Then we're going to use Arduino as a transmitter or as a remote, so we can turn on and off a TV or other devices that needs infrared. Next project, we are going to control an AC bulb or a relay, so you can control AC bulb or DC bulb or load, whatever you have. Next project, we are going to like this. When I press it, it rotates now right, stop it, and then rotate it left. And final project will be to control a servo motor using infrared. Hi, welcome to an Arduino step-by-step course by Robojax. We're going to see how we can use these two remote control and detect them. I will also show you how you can use your own remote for any TV or another player that you have, using Arduino to control devices or turn on and off something using Arduino with any remote that you have. The link will be provided for the library, but for this one you can use either this actual small module like that, bare module, or maybe use as a PCB. Does not matter. These remotes are majority of the codes are the same, but because it has more keys, this has 21 and this has 17 keys. So for that reason I have written code, so you just type or select the type as a B for black or W for white, and all the code will work for you. They're sold on eBay. Both will come with either with this I've bent this, but with this receiver, or you will get this receiver on a PCB. Decoding varies, so whatever this decodes is different or receives than this. So this receives one thing of the same remote and this receives the other thing. For that reason I have written the code to make up for those difference, and once you receive your package, whatever it is, this or this black or this white, it should just work fine. So we are connecting it to Arduino, and the result will be displayed on the serial monitor. Some of the kits that is sold also, they give you this infrared transmitter, so you can send signal and detect it with this. So this one has written on it VS1838B, and this module has also written on it VS1838B. As you can see, the legibility of these two varies significantly. Let me put it at some angle so you can read it better. You see, on the left side, this PCB seems to be very hardly, not as legible as the one that is on the right. But regardless, both of them work perfectly fine. And the beauty of this PCB is that when it detects or receives code, this light blinks, which is very good. It helps us understand when the code is received. There's a data sheet. Some manufacturer label it as TL1838, and in terms of voltage, operating voltage 2.7 to 5.5 volts, receiving distance 10 to 15 meter. This is very long. And the quiescent current, when there is no signal, we are getting typically 0.8 or a maximum of 1.5 milliampere. And here they've explained the frequency, which is 38 kilohertz, how the waveforms are outputted from this device. And this is the angle of operation, 70 degrees, and the distance they show is 15 meters. And the input frequency here, again, the transmitter must send the 38 kilohertz to get it. Let me explain now the wiring. So you can either use this as a module or use this module without a PCB. In both cases they are the same. If I hold this like this, this is the VCC, this is the ground, and that is the signal which will be connected to pin 11. See here, this one says negative. The right one is connected to the ground, the middle one is connected to 5 volts on Arduino, and the last one, which is labeled as S, the signal, it's connected to pin 11 to VCC, and then ground, and this is for the signal which will go to pin 11. Make sure that you understand that this is a flat side and this is the side that you can see on the picture, and the signal is on this side as shown here. First, let's install the library for this project. Click on Sketch, Include Library, and then Manage Libraries. Wait for this screen to show up. Wait for this bar graph to end so you can type. Now type here IR remote. Wait for this and the screen will change, and this is IR remote. As you can see, it says installed. In your case it's not installed, so you will see install. In this case I see update. Just click on install here and wait for this bar graph to complete and then close it. You go on file, example, and then there will be IR remote. You will see all of this. If you see all of this, then you have the library and we are good. Installing library is completed now. When you install the library, this is part of the library. Receive pin 11. So we set the pin 11 or whatever pin that you want to use. In my case I used 11. And then the type, here you type either W with capital or B for black, W for white, and it must be inside single quote. Double quote will not work. Make sure to follow that because it's character. In car type you put single quote and then PCB, and if you're using this one you put PCB equal 1, and if you're using this module just put equal 0. And then we are initializing we are creating an instance of this class with passing the PC input pin for the receiver. And below this line, except these three, you do not change unless your remote control is totally different. Otherwise, for these two remote control it works fine, and I've created one array called white remote PCB. So this is the code for the white remote when you're using PCB module, because this PCB module reads it one way and this reads it the other way. So these are the code for that, for channel minus channel. These are all the code for that, for all the keys. And then we have another array of type integer. Here it says white remote. This is without PCB, and this array will be used when this module is there. So you don't have to worry, it will be taken care of automatically. And after that we define the keys for the white remote. So these are the keys. When the code is detected, we print this on the screen telling what key have been pressed. And this is for black remote. These are the values for this black remote when without PCB. And this is the black remote, and we have PCB at the end. These are the codes for the when you use PCB. And these are the black remote key name or labels. And this is the result. When the code result comes, this is an instance of this class. Inside the setup we have 9600 baud. When I press a monitor here, this is very important that it must match 9600 baud, otherwise you will not be able to read the text. And this is just a text on the screen. IR receive enable RI pin, so this initializes a pin 11 to start receiving. Inside the loop, this is very simple. Here it says IR receive dot decode, and we pass the result to it. And here we get the result dot value is our result, so we pass it to Robojax validate code that I've written, which is below. I'm going to explain it next. And then IR resume. This just resumes the loop, waiting 100 milliseconds. It continues. In case if you want to read the actual code that is sent by the remote, just remove this, make it uncomment, and it will print the code for you on the serial monitor. Otherwise, this will be just a decoded code like CH21 or whatever key is pressed will be displayed. Now let me explain this code. When you pass the result, it comes to this function, and we call it CD, the code that you pass, the decoded code. So CD or code. This integer found is an internal variable that I use to validate the code found. Here we check if type is equal. These two equal means comparison or comparing, so equal capital W, and PCB not equal true. When you set it equal 0, that means not equal true. So we check if it's not PCB and it's white, then this code from here to here will run. So this is a loop that runs, and here it gets the array of white remote without the PCB and checks it, and if the code that the user entered is equal, the user entered is equal this value of array with I is 1, 2, 3 up to all those numbers, and then we press the key pressed, and from here we get the text white remote key, so the key name will be printed, and we also set this found equal 1, so later on will be used. Otherwise, if the type is equal W and this 2 ampersand means and, so this must be true and this must be true. We just put PCB. I didn't put any equal sign because it's a boolean. We can use that way. I could use equal 1, which is extra, so this would work, but I just put it PCB, which means if it's true, this must be true and this must be true. If that is true, then we run this one, which has PCB. And else if otherwise, if the black one, if you use the black one, then again, if with a PCB, this code will run. Else, which means all the possibilities are eliminated, so then it must be without the PCB, would be this module, then this code will run. When that finishes, here is the found will be used, the found variable. We say if found is not true, that means not true, then we check for something. When you press a key continuously, you get FFFF, so we say if it's not equal this value of hex integer, then we say key unknown, because it's not found and it's not this, then we pay unknown. The job of this F condition is also to eliminate this FF, so you will not see it on the screen at all. And if you want to do, let's say if OK is pressed and you want to do something, or this arrow on the right side, whatever, just for simplicity, let's say if OK is pressed, this for black key, this is for the checking the black key remote. So here we say if this value is equal, inside the double quote put OK. Here we can set a pin high. I'm going to say pin 9 high. So this will just send signal to pin 9 of this Arduino, and it could be a relay, it could be motor, it could be light, whatever you want. You can do the control like that, and you can put multiple conditions for each key. You can do different thing here. Once you install the library, you can go to File, Examples, and then you should see IR Remote. Then Receive Demo. Select this one, which is this code. Make sure that this is pin 11. If you're connecting another pin, just change it to that pin that you are using, and then open the serial monitor. Now this is a serial monitor. I'm just pressing a key here. So this is the actual key that is coming from the keyboard. This FF is as a result of continuous press. Let's say I'm pressing 8. You see, this is all FF. Initially at the beginning it receives the code, and after that it just prints FF. See, I press it only one time, that's the code. and another time, that's a code. But if I press it continuously, I get that FF. Same thing with this one. If I press it continuously, I get those value, and if I press it just once, this is a value, and that was a moment that continued. So this device receives continuously the signal, and as soon as it gets the signal, after that, if the same signal is received, it just prints out this FFFF. For that reason, I've put the code in place to remove this and only print the key that is known, or if the key is unknown, you will get unknown value. I think the LG remote, this is for TV. I press volume down. As you can see, this is actual code, but if I continuously press it, I will get FFF. That is from the decoder. If I press 5, those are the values. Favorite. So we can read any remote's code here and then decode it, and based on that you can turn on and off something with this remote using Arduino. If you want to use any remote that you have and by pressing a key do something with Arduino, you can just modify this code that I have, read the code the way that I shown you, and then put them here accordingly. That just 0x is at the beginning, and the code that you read, just put it here and put the code reference for yourself, and then the code that you have, and put the labels for each key, and then take some action based on the key using Arduino. Now I'm demonstrating. I've set this to white, to W, and then PCB equal 1, and this is the PCB version of the code. So this is the PCB version of the code, and then let me, if I press CH plus, we should get this code. So this is now also printing the code. So this is the code that this printed, and also it printed CH. For this double arrow to this side, we are getting this B1B. For the plus, we are getting that one, and so forth. So I've enabled this to display the code. If I just comment this out, we'll be getting the key that is pressed. Sometimes it gives you error. That's due to the quality of these keys. Now I've set this to W, which is white, and PCB equals 0 because I'm not using PCB, I'm using the other module, and I have to hold it with my finger again in order to eliminate any false reading or noise. Equal 100 plus 2 6 left, and then channel. So if you are using it, make sure to solder it or have very tight connection, because this DuPont wire that I'm using, the wire for this pins are very thin and it's loose. As you can see, it's reading very well. This to B for the black, I'm testing the black, and also PCB equals 0 because PCB is not used. As you can see, because this is very loose with a connector, we are getting some of those values, but if I hold it tight, we will get the right value. Left arrow down, I'm pressing OK. So 5. Sometimes you will get some error due to the key quality, but generally it works very well. Now I've set the type to black and the PCB equal 1 because I'm using PCB, not this bare module. So I press OK and it prints OK. Right arrow, down arrow, left arrow, any of these numbers that I press, it will display. From time to time you might get error due to the quality of these keys or some other noise. Please make sure to subscribe by clicking at the subscribe button in here. Thank you. We are going to see how we can turn on this AC bulb or load, or maybe DC, using infrared, remote control, and Arduino. So we turn it on and turn on the relay, and relay will control this. When I press the remote, the light is on, and when I press the negative, the light is off. Also, I'm going to show you how you can use your own TV remote to turn on and turn off the light. The whole purpose of this video is so you are able to use either the black remote control or this white remote control, and the receiver with PCB, or the receiver without a PCB, this VS1838B, to be able to turn on an AC bulb. Or maybe you can use your own TV remote to turn something on and off. Take action for. I'm going to show you how to set a specific button to control the relay. For example, I've set the plus sign on this white remote to turn the relay on, and the minus to turn it off. So you can set any of those you want, or maybe in this black remote you can put this left arrow, right arrow, or top and bottom, whichever you prefer, any of these buttons to be able to control with one button and turn it off with the other one. In many countries you cannot insert this plug in the other way, so live and neutral are always in the same position, but it does not make any difference in terms of safety, because in many devices or loads the current goes from one wire, and even if you disconnect the live will come back here. It will appear here. So what it means is this is very dangerous to be touched. Once the plug is connected to the outlet, do not touch this relay. If you want to work with this, disconnect it and then work with the relay. That's for safety purpose, because safety is first. So let me explain the AC bulb here. So this is a table light to the wall outlet, and the wire goes and will be turned on. But I have disconnected one of these two wires here. I've just cut this wire from here. Now this can be connected to the relay. The relay job is to just connect it, so it will be on, and disconnected will be off. I've just twisted them and then put some solder so this can be inserted into a connector with a screw. To briefly explain the relay has 3 pins here for the load. Some of them will have proper English writing. This is Chinese, but it's just by chance that I got this. But in this side it has been labeled properly. So the 3 pin that you're connecting here. So here we have VCC, we have ground and N. VCC will be connected to 5 volts ground, and this is connected to pin 2. But on this side we have 3 wires, 3 pins. So what happens is you will connect 2 wires that I showed you. One of them will be here, the other one will be here, either on this side or on this side. In this side, this is normally open, which means when the relay is energized, it will turn on. In this side, this is normally connected. So as soon as you turn it on, or maybe if the Arduino and everything is off, it will always have connection. Once you send the signal, it will turn off. So in case your device is behaving in reverse, keep the middle wire in the same position and just move your wire from here to here. But for this project, I will suggest to connect the wire in here and here, because this is normally connected. These 2 wires are normally connected, so you will connect between this and this, which is normally open. And in terms of power that you can connect to this relay or any relay that you're using, make sure to pay attention to the rating of this. For example, this relay can have 10 ampere at 250 volts AC. This is in Europe, Asia. Majority of those countries are using 220 or 240. So 10 times 250 is 2500 watt. This can handle. If you're in North America, this will be 120 or 125. So 120 times 10 is 1200 watts. So this can handle 1200 watt. If you're connecting a DC load, just multiply this 30 times 10, that's 300 if you're using 30 volts, or this is almost the same. So make sure that you understand that total current that can pass through this is 10 ampere. So if you overload this, you might create fire, so make sure to not overload this. Pin 11 is for the receiver from the infrared. So if your pin 11 is occupied or you want to use it for other purpose, change this. W refers to the white remote if you have. Otherwise, if you're using black remote, just type this B. These are the exact remote that I have So you will put either B or W capital and also put single quote around it, not double quote as explained. And if you're using this PCB, set PCB equal 1, and if you're using the bare module, just set it equal 0. And if you want to display the code here, for example this code which is displayed, set this equal true. If you don't want to see the code, set this equal false, like this with a small letter. This portion is for the relay. So I'm using pin 2 here to control the relay. The relay will be connected to pin 2. So you set the pin that you want to use here. Any digital pin from 2 to 12 in Arduino, or maybe other Arduinos that you have put. This on and off, this is the key. For example here, the 3 is set to turn it on and 1 to turn it off. For that purpose, set the key, exact key that you have here in this list. Exact key that you have, it must match there. For example, if you want to put channel minus, for example for this one, you must put CH capital with minus. So this is the key, and below this you do not change anything. This is for white remote using PCB. So when you use this white remote and then PCB, these are the values. Then white remote without a PCB, when you use this one, these are the code that I have put here. This is white remote keys, all the keys labels have been explained here. And this is for the black remote, and then we have black remote with PCB, and then we have black remote keys explained here, upper left, okay, right, and then I put V here for below, for these 4 keys. And inside the setup, important part is here that we set pin mode, the relay pin, which is now pin 2 as an output, and also immediately we set it at high. High means in this relay, this is low trigger, with high it will go off. So that's why we set this high, so we turn off the relay at the beginning. And then this loop will continue working for you. The portion that is not included with the previous code that you watched is this portion, relay action. Inside the code I put this relay action, and then I pass the key that is pressed, plus, minus, any number that it is. So this will come from all these 4 portions: black remote with PCB, black remote without PCB, white remote with PCB, white remote without PCB. So we are passing the value to the relay action method, and here the relay action method will receive the value as a string, and here we check if the value on, this is a value that you set here for on and off. These are the value we are using down. So we say if that is equal on, relay pin low, low means energized or turned on, and then also we print the text here, and then if it's off we do this one. Other than that, nothing happens here. To demonstrate turning this light AC bulb on and off using this remote control Arduino, this receiver that is connected to Arduino, and relay, and this AC bulb. So you can control not only bulb but anything else, motor or anything that you want, or maybe DC, but connected to through the relay, so relay can turn it on and off. Now pressing the plus, the light is on. This relay has a light, but it's not necessary. You can have a relay that does not have a light, so it will be the same. Now turning it off, it will go off. Also I've created the serial monitor, so it can tell you that which key is pressed and what is the status of relay. In case you want to disconnect it from AC and just work here, this will tell you, and also relay will click. So turn on and turn off. Now this is the PCB version, and I'm using the white remote. If you want to use this bare module without that PCB, we have to do 2 things. First, in the code we have to select the PCB equal 0, and that's it, and then upload the code. Connected this module. Now the module is standing, not moving. AC is now connected, that module is there, and it works with that one. If I do not select this code, PCB equals 0, it will not work. Make sure, because this is not the PCB version, without the PCB, just bare module. So if you put 0 when you use PCB, make sure you set this to 1. Now this is W, it means that's a white. I'm gonna switch it to this black. Using the black, we don't have this plus and minus that we had here, so we can select other keys. For example, we can select 6 to turn it on and 4 to turn it off, any of these. Let's go with the 6 and 4. For that reason, for turning it on, I'm gonna put 6 here, and for turning it off, I'm gonna put 4. Upload the code. By default, it turns the relay off. Let me turn it on. So I pressed this one, and then let me turn this on. Turn off, turn on. So it perfectly works. Now to use the PCB module, the same thing. So we have to make sure that we set 1 here for PCB, upload it, connect the PCB. Now PCB module is installed, the code is uploaded. I'm gonna press 6. It's working with PCB now. 4, turning it off. Now I'm gonna show you how we can use your own remote to control this AC light. So first we have to capture the code for this remote. In order to display the code, we display code, we set it equal true. This will display the code here for us. That's the first thing, and then let's capture it. For example, in this case, I want to press 3 to turn on the light and press 1 to turn it off. I'm pressing the 3. It shows unknown, but it's okay. So make sure you press it 2 or 3 times, and you have to get consistent value. So that's all of them are ending with 9F. That's correct. I'm gonna just double click and copy it, Control C. I'm pressing the 3. It shows unknown, but it's okay. So make sure you press it 2 or 3 times, and you have to get consistent value. So that's all of them are ending with 9F. That's correct. I'm gonna just double click and copy it, Control C. And then this is, I'm using white PCB. Go with this one and find the digit 3 here and replace it, and keep the 0x. Now I'm pressing 1 to turn off the light, and then capture the code first. That's 1. You see 20DF. Double click, copy, and then come here for the 1. This is done. Now after that, turn on. We have to now set 3 here to turn on and tell our program, and 4 to turn off. Oh, sorry, 3 to turn on and 1 to turn off. This is true. I've changed the code for the white remote. Make sure to set this to W. And because I'm using this PCB, make sure the PCB is equal 1. So W refers to this code that we changed, white remote, because we were initially using this white, so I'm just replacing it. And after that, upload the code. Now I'm using this remote, pressing 3, the light is on, and pressing 1, the light is off. 3, light on, 1, light off. The same way you can do for any other remote that you have. We're going to see how we can decode any remote for TV, Blu-ray player, DVD player, whatever you have. So we will decode it using Arduino, get the code, and after that we will send using this infrared transmitter to control the same feature of this. For example, turn on the TV or turn it off. When you press any button on your remote, actually it sends a code, and that code in 38 kilohertz, it's being decoded by the receiver. This is one of the example of the receiver, or maybe this one, which is in your TV or whatever device that the remote belongs to. So once the infrared signal receives there, it decodes it, and based on the different button that you press, it executes the command. For example, it turns off, turn it on, increase the volume, change the channel, whatever you do to control your TV. Let's say you want to turn it on and off, and this is, for example, I have a Samsung TV at home, which I'm going to test and show you. The on and off in TV works in such that if the TV is on and it receives the power signal, it will turn off, and if the TV is off, if it receives the power signal, it will turn on. So we are using only one code to control that, and I'm going to explain it to you. First step, we are, for example, turning on and off this TV. This is a Samsung TV. So we will use the power button and capture it. Volume and others, they will have 2 up and down. So we will use this one. We will capture only one code. I will show you how to do that, and after that we will run this again as a transmitter using this infrared transmitter. This is just LED type. It looks like an LED, but this is actually infrared, and we have only around 300 ohm resistor in between, and it will be just execute the code for us to turn the TV on and off. So there are 2 types of receivers sold on eBay. One is the actual receiver without a PCB. The other one is the module with the PCB, an LED that is related to the signal. So when it receives the signal, it blinks, it helps you. But my test will be on this one, and in this one we have here negative. This goes to the ground, the middle one goes to 5 volts, and there is on this side it says S. This goes to the signal. If you are getting this one, this side is flat and this side has this grid. This is the VCC ground, and this is the signal which you connect to pin 11. And this one, the signal also goes to pin 11. In both cases, if you're using this one or this one, I would suggest connecting it to pin 11. Otherwise, if you're changing the pin that you're connecting, make sure that it reflects it in the code. For this one, you have no choice but to connect this to pin 3, because the pin has been defined in the library. If you want to change it, you have to open the library and change it. This resistor is 300 ohm, and you can put 270 up to 320, and these values, all of these will work. The only difference is if you put higher resistance, the power of this will be reduced and it will work for the shorter range. But if you increase the power up to certain range, depending on the specification of this, let's say if you reduce it, the value of this, the power will increase, and eventually this will be damaged if you send more voltage to this. 270 to 300 ohm resistor will be suitable for this one. Otherwise, consult the data sheet for the receiver and calculate resistors accordingly. The thing that you need to change is here which pin you are receiving the signal from the receiver. So this is pin 11. If you want to use other pin, just change it. Other than that, you do not change anything in this code. Be just using it as a decoder. So you will set the right pin here. I'm using pin 11 to receive the signal from the receiver. Other than that, you don't do anything here, and once you run it, it will just display the code to you. This is connected, turned on, and that's the sketch. Let's just upload it. To send the code, go to File, Example, IR Remote, and then use this one, Send Raw Demo. Open this, and now the code that they give you, just paste it here. Delete all of this inside the loop, and I just left 5 1000 millisecond delay. I just pasted it. Now you see the raw, this is the array that is holding the code for the remote. This long, it has so many elements already there, and the name of this array is raw, and it has 68 elements. Here we say send raw, then the array named raw, and then 68 is the length, and then 38 is the frequency. If we send this, and if we connect, now we don't need to have this receiver, we can remove it. If you want to leave it also, that's fine. Done. And if I upload it, now the code is uploaded. Now every 5000 millisecond or 5 seconds, this sends a signal. The TV is in the other room, and we are going to turn the TV off, and then if it's on, will be off, and wait 5 seconds and turn it on. But before going to that room, let's just use I will use another Arduino to decode this and see if we are getting the same code. I'm going to another port 8, which is this. Now connect it, upload the code, and then open serial monitor. Now this is sending the signal, and that one is receiving it. Okay, so we are got this signal. Okay, so I'm just connecting it now. Let's see, the code that we got is the same code as the other one, F4B82988, and this is the code that we received. Exactly the way that we press this remote. Now this is acting as our remote. So I'm copying this code that I received, and I'm going to paste it. And here there is some small difference. There are differences between the codes, and let's test it and see how it works with TV. Now I'm testing it. Here is my Arduino. The code is already uploaded, it's connected, turned on, and the transmitter is here, but I have not connected this. As you can see, the TV is off, and here is the remote. I'm going to leave it here. Now connecting this to pin 3. Now let's see if this turns the TV on. I heard the noise. The TV is on.
Okay, remember, get outside, get into nature, and make your own discoveries. Hello, folks. It's me, the conductor.
And the TV is off. So it's perfectly working. And now 5 seconds passed. Now it will turn the TV on again. And the remote is here. You can capture any TV or any device's remote and use Arduino to control your TV or whatever device you have. You can do more complicated. For example, you can have a satellite receiver, or let's say you have a Blu-ray player and you want to turn on the TV, and then after that turn on the Blu-ray player, set the input of the TV to, let's say, HDMI 1 or HDMI 2, and then play the Blu-ray. And then set the volume at 50%. All of this can be done. So for each you have to capture the code. For example, for input selection, press this, select the input. Let's say in your TV for HDMI 2 you're pressing this 3 times or 2 times until HDMI 1, HDMI 2, and then you capture that, put it in a sequence on your Arduino to be transmitted in here. And so you can have, I put here, I called it Samsung Power. So you can have these 2 lines. Again, you will have Samsung input selection, and after that you can have another line for DVD player power, and then DVD player play. So whatever you have 10, 20 lines you can have it, and the Arduino can execute all those codes. I'm going to show you how you can control a DC motor using infrared remote and infrared receiver with Arduino using L293D. After that, then come and use this combined code that I've provided, and for sure it will work and you're able to control the motors using this remote control. Now let me explain the wiring for this chip. The first thing is that pin 16 goes to 5 volts in here, which I'm going to connect this portion to Arduino, and here it shows pin 16 to VCC1, that is the 5 volts. Pin 4 and 5 are connected together, both of them to ground, and here pin 4 is connected to pin 5 and both of them are connected to ground. So this is my common ground. Here we have, for the motor, I have 4 diodes here. Anode of 2 diodes are connected, so one diode is connected from ground, and cathode of this is connected to anode, and this is connected to VCC2 voltage for the motor. So the one pair, and then I have another pair, so 2 pairs from ground, anode, cathode of this to anode of this one, and this is connected to the positive. Now let's check here. So I have one diode here, anode, and that's cathode, and this is anode, that is cathode here. The anode of both of these are connected to ground. And now look, this one which comes and then anode and cathode goes here, this anode, and then cathode of this one is coming here to the anode of this. Both of these are together. From here we will connect it to the main power supply, the 12 volts, 9 volts, whatever is the power supply for the motor. So this goes to the power supply of the motor, and this one goes to 5 volts of Arduino. I will remove this for now. Pin 3 and pin 6 are connected between anode and cathode of one diode, and then 3 is connected between the other one. Doesn't matter which one is which, so I'm connecting pin 3 to the middle of these one diode and the other diode that are coming together. And here pin 3, this is pin 3, 1, 2, 3, and I'm connecting it and here between these two diodes. And here I've connected pin 6 to the middle of these two diodes. So this diode is coming here, the cathode of this diode and anode of this diode. That's connected to pin 6. Now here is a motor. For the motor I have 2 wires. The wire for the motor will go exactly between anode and cathode of one group, which is here, and the anode and cathode of the other one, which is this blue. This is exactly the same as if we say pin 3 is connected to the motor, and we can say pin 6 is connected to the motor. So pin 3, blue, is connected to the one wire of the motor, and then 6 is connected to the other one. Because the direction of rotation of this motor can be switched, doesn't matter which one is which, but if you have some preference, just switch it, remove this and connect it the other way. From pin 8, that's coming to the pin 1, that's the enable, that enables this portion and this portion, both sides. So pin 8 is this gray wire here. I'm gonna connect it to pin 1. And pin 7 of this chip, I have arranged it such that pin 2 will be connected to pin 2 of Arduino, pin 7 will be connected to pin 7 Arduino. This is connected to pin 7, the white, and I'm going to connect it here to pin 7. And that pin 8, pin 7 is here. This is connected to the VCC to 5 volts, this portion, and this line. And this line is connected to the ground of Arduino. I've connected this wire to 9 volts of external power, and this is to the ground. Ground is connected to the ground, which is connected where this yellow to the ground of Arduino. If you're using this PCB, the signal goes here, this goes to pin 11, the middle goes to 5 volts, and then here it says minus, this goes to the ground. If we are using this bare module, here are the pins. VCC from this side, VCC, ground is the middle one, and then this goes to pin 11, which is the signal. Connected the signal to pin 11. Ground if have been connected here, VCC is connected here for both of this PCB module, and without the PCB, the receiver. A black remote, just type black inside a single quote, and if you're using white remote, just type capital Y. Also, if you're using this module, or I call this PCB, so PCB equal 0 if you're using this one, and if you're using this PCB, set this equal 1. This false or true display is to display the code here. This is to display the code here. If you want to know the code, set this equal TRUE, true. We have 3 commands here: right, left, stop. If you're for the right, we have to know which command or which key we are using. And for example, this is for the black remote, capital B, so right arrow inside the double quote, left arrow inside the double quote, or OK. This must match the code that is the label of the remote here. These are the label for the remote, and it must match, otherwise it will not work. After this, you do not change anything, you just go and read it. So this is for the black remote with PCB. These are the codes, these are the hash code. This is a white remote code for decoding purpose. This is a white remote key. These are the labels for this remote. I've put them in 3 because each row has 3 keys. And this is for the black remote, the code for the black remote with PCB. When you are using a PCB version, the code will change. And these are the black remote labels, and these are the labels that we need to know. This is the up, left, OK, right, and then down. We have 4 keys here, and I put them inside the double quote, and the key that you are selecting to control it must match. So this is the way it is. So this key that you're using must match this, otherwise it will not work. P1A is for the DC motor. We set pin 2 and pin 7. These are the 2 pins. So this is for pin 2 and pin 7. These are the input that is coming from Arduino, and pin 8 is enable 1, 2. That is will be connected to pin 8. So if you are using the pins for other purpose, change this accordingly between 2 to 13. And pin 11 is here for the receiver as well. Make sure to set this 11. If you're using different pin, set that accordingly. So this portion is for the motor, and this is for the receiver. Inside the loop, we check if the code result is true. So this means if true, then we do all of this. So see what we do. We say if the display code serial. So first, if we set the display code to display the code for us, then we print it as a hex value, and also we say Robojax validate code, and we pass the result dot value, and then infrared receive, resume, and we wait 500 milliseconds, and the loop continues. This portion is done. I explained the validate code in my other video. The only difference is this was a relay action or some kind of action. Here I put as motor action. This is the line which passes a value for the remote. This is the value that is printed on the screen. Also we are passing it. This is when we have white remote with PCB, white remote. This is when we have white remote without PCB, white remote and PCB. This is a black remote and PCB. And else, this means black remote and not PCB. In all of those, we just pass motor action and we pass this value. So the motor action will take the value for the remote. Now let's go for the, and this is the motor action, and we see, we check it here. If we say that if the value that we pass is equal the right, this right and left and stop, or the values that have been defined here, right, left and stop. So we say if the value is equal right, we say L293D, R mean right and 1 mean enable. And for the left, we just call the same function, left, and then 1 mean enable. And if the value is equal stop, this doesn't matter right or left, but here is the important part, 0 mean stop. And here L293D that I've written, it receives two parameters, a character and then 0 or 1. And the character arrives here, we call it dir, direction, and enable the value, the other value that's 0 or 1, we call it enable, en. And here we check if dir or the direction values, this is double equal sign, which means comparison, left. Then here is what we do, then we say if enable is there, we just say motor stopped, and if the enable is not there, we say motor is rotating, and then we enable the pin. So this is pin 2. Enable mean if it's 1 it will be enabled, if it's 0 it will not be enabled, and then we send pin 1A and pin 2A. One is high, the other one is low. When we have this equal right, then here the difference is this will be high and low, and here will be low and high. So this will change the direction of the motor. And automatically if enable is equal 0, doesn't matter left or right, the enable will pass here in both cases and the motor will stop. Let me now demonstrate it. I'm using the black remote to control the DC motor, and on the sketch you have to set the type of remote, B for black, as it has been explained in my original video, and PCB is equal 1 because this is now PCB, and false display is set to false. I'm using this right arrow key for the, so for this controlling remote we have 3 commands, for the right, for the left, and for stop. So we have to have 3 different commands in order to control motor to rotate right, left, and stop. So when it will be counterclockwise or clockwise, so I just use right and left. And this remote has labels. As right, I'm using this right arrow to move the motor to the right or clockwise, and then this goes counterclockwise for the left, and then there is OK button, which I have filled this up inside the double quotation. So these are very important. The black and white is also single quotation, and then PCB is equal 1 because I'm using PCB. I'm gonna also test this one without PCB. And press it to the right, so counterclockwise, rotating, stop it, and then clockwise. I've set these 2 different LEDs so you can see the change in colors to tell you which direction it's rotating. You can directly go to the other direction or just stop and then go to the next direction. For this silver remote, we can use these labels that I've defined it inside the code in the original video. So either we can use this, or any of this that you want. For example, we can use plus, minus, and equal. So this one, whichever you prefer. Let's go for the channel. Channel plus to the right direction, to one direction, channel minus to the other direction, and CH. So here they have been defined exactly here, CH, capital CH, capital CH, capital CH with a plus, minus, and the middle one, which is CH, it doesn't have anything. So we have to define it first. So this is white remote or silver, so I put W because we're using PCB, so that's PCB. And here let's put CH plus so we are defining the key that is there, so and PCB is equal 1. Let's upload it. So pressing it to the right and then pressing the middle one to stop, pressing the left, directly go to the right, stop, now I have removed the PCB module, just the bare 1838 module here with the silver. The only difference at this time is that I set PCB equals 0. Let's just test it. Pressing this channel plus, CH plus, stop, and then channel minus, so clockwise. You can go directly clockwise or stop. For the black remote, I've set type capital B and PCB equals 0 because this is not PCB and PCB is here. Now with the black remote, this key, that arrow to the right, rotating, stopping, go to the left, stopping. Thank you for watching. This was how to use these two remote control with Arduino to control a DC motor, change the direction and stop it. In this video we are going to see how we can control a servo motor using a remote control and Arduino. I'm pressing the button to move the servo to the right, or maybe move it to the left, or just press the center. Your home remote to control the servo. To control the servo either with this white remote, with a black remote, or with a module with a PCB, or without the PCB, with a bare module. And also at the end I'm going to show you to use your home remote to control the servo. That you can use this servo or larger servo or this micro servo, doesn't matter, you can control all of them except with this one, with the larger one, if the Arduino is unable to provide enough power for it, so you have to connect it with the external power. Let me explain the wiring. The servo has 3 wires. These are the 3 wires. The dark one is the ground. The middle one is always the 5 volts or a power. So you cannot make mistake even if you flip it. It will be always at the middle. And then the lighter color usually is the signal. And this is connected to the ground, as you can see here. And the red one, which is here, the white, connected to 5 volts, and then the orange I've extended with this wire. This is the gray. This is connected to pin 8 and Arduino. For this module we have 3 wires here. We have ground, which is connected to the ground. We have the VCC connected to 5 volts, and then we have the signal connected to pin 11, as explained in my original video. Now this module has been explained there, that has negative on this side. This goes to the ground, the middle one goes to the 5 volts, and S is signal, which goes to pin 11. If you use this module, this is VCC, this is ground, and that's the signal, and I will connect it to this wire. I've bent the pins up for this so it can receive the signal easily. Let me explain the code. From here to here, this is for the servo. This is the library for servo, which is part of Arduino. You don't have to download anything. And here we create an instance of this servo, RJ servo. The Robojax servo is initiated, and we are connecting our servo to pin 9. So we create a constant here, and the angle, the initial angle whatever you want to set. For some cars, for some equipment, you need to put a certain angle. If you don't have a fixed value, just put 90, because the servo moves between, moves between 0 and 180, so 90 will be at the middle, which is appropriate value. And then angle step, this is the resolution, or how fast the servo should move. Every time you press it, this goes 10 at the moment. But if you want to make it 5, so change that, so you have to press it multiple times in order to make it move. You cannot press this continuously, because the detector will detect FFF and it will not work. Here the angle center, so you can set another angle when you press, let's say with this we go right, left and right, and with OK we bring it to center. That center is this value. So when you press the button to reset, I should have called this reset. So this is the reset angle. And then this is for the remote. I've used in this example, this is a right key, this is the arrow, which is part of the code that I've explained, and this is for the left. So when you want to move the servo to the right, this button is pressed and we have to put it inside double quotation, very important. And for the left we put it there, and for the center or reset, OK, this is O and K capital inside the double quote. So this must be exactly the same. And if you're using this remote, let's say you want to use this channel plus for the right and channel minus for the left and CH for the middle, you have to put exactly as it is. And I forgot to mention here, if you use this remote, we type here capital W inside single quote, and if you use this remote, we type B as a black. And if you're using this module, we set PCB equal 1. If you're using this module, we set PCB equal 0. After this line, you will not change this. This is the white remote PCB codes. This is the white remote without PCB. And these are the key for this white remote. All the values are here, so that's why these must match with the above setting that I mentioned, so you can control the servo. And this is for the black remote with PCB and so forth. The important part that has changed is this one, so we attach a servo pin, which is pin number 8, to the servo, so we must type rgservo.attach. So this is extra with comparing to the code that you watched. And then inside the loop, nothing has changed. This is exactly the same as before, and we have 50 millisecond delay here. This is the same as original code that I have created. And after that, Robojax validate code has not changed, except I put here servo action. In my previous video it was relay action and some other stuff. So the job of this one is validate code, to validate the code for us and take some action. Here we put servo action and we pass the value that is received to this function. And this is for the white, which is when it's not PCB, and here this is for white PCB, same thing, exact same line. And then for black PCB we have the same line, and otherwise, which is PCB black with non-PCB. And here is the servo action that I mentioned. The servo action receives the value as a string, and here we check the value if the value is equal right. The right is the value that we define here. Right, left and center, the 3 keys. So we say if it's equal right, we check if the angle at the beginning, let's say it's 90 or 0, if it's bigger than 0 and smaller than 180, because when you increment the angle, it usually goes above 180. So we have to make sure that we don't allow that, or maybe if you go for the left side, if you go to the 0, again you will reach to minus below 0. So this is preventing that. and adjusting and fixing. And here is a point that sends the signal to the servo, the angle that you push, and this is just a text here will display on the serial monitor. And then here we set the value to dot. Dot is something that I picked because it's not in this remote, not in this remote, so that was unusual point. So once you release the remote, this just sets it to that dot, so it will not take action. And then we wait 100 milliseconds and it continues. If you press the button, it will do it. And for the left, we do the same thing. And if we are center or reset, when you press, let's say, OK, then we set angle equal center angle, and then we pass it. That's why the servo goes to the middle. Now let me demonstrate controlling the servo. I've opened the sketch. The first thing that we do is I'm using the black remote. So for that I have to put here B for black, and because this is a PCB and not this module, I set this equal 1. After that, here because I'm going to control going right with this one, so that is the arrow that is printed. Unfortunately they printed black on dark blue, so you cannot see it properly. But on the left, for the left and for the center, press OK. So this will reset and bring the servo back to normal. The serial monitor. Now if I send the signal properly, it will respond. I'm pressing it to the right. You can see it shows now it was 90, now it became 80, 70. And if you pay attention here, I have set the steps angle step 10 degrees. For that reason we are going 10. So you see 40 degrees. If I press OK or center, it goes back to the center, which is 90 degrees. Now if I press left, same way, it goes to the left. I've set this now to white. I'm using the white remote, and PCB is equal 1 because it's PCB. And I'm using this one with a CH plus to the right, CH minus to the left, and CH back to the center or reset. Now the serial monitor is open. You see, sometimes you get unknown because the switches are not properly contacting or sending the wrong code. And reset works. I'm pressing it back. So 180, that's the maximum. And after 180, you see when I press it, the command goes, but the program prevents it. And then press center, it goes to the center. I've set PCB equals 0 because I removed the PCB and I put this tiny module with the wires, and it's white W. Same way it works, and CH will bring it back to normal. Now I'm going to capture the code for this remote and control the servo instead of these remotes. So let's use the black remote. When it says black remote, because this is black, I'm just using the word black remote. And then let's check this and set it to B. This is black remote and this is not a PCB, so B black and PCB is equal 0. Now I've set this display code equal true, so when I press the keys here, it will display also the code. I'm planning to use this arrows, right, left, and enter. Pressing the right arrow will move this to the right, and pressing the left will move it to the left, and pressing enter will reset this. So that's my plan. First I have to capture it and see. I'm pressing the right. If I press the right here, it says unknown, which means none of the key matched, so that is good. Now with the current remote that I'm using with the black, now I'm pressing left, left also doesn't match. You see unknown, unknown, but we are getting the code. And also let's try enter. So all of them matched, but it's possible that some of the key that you press and it says CH is pressed or something. This is a black remote. I'm gonna use this right and then left, replace these code, and for the OK I'm gonna put enter. This is just common for myself, so I'm gonna capture the left one, which is this one first. Let me open a new monitor. So left, this is the code, double click, Control C, come here, this is for the left, I'm putting it here. You see 659, and then let's go for the right, 6B9. So multiple times is good. If you get consistent value, that's good. Double click, highlight, and then Control C, copy, and I'm gonna replace it in here. And for the enter, 6E9, consistent, that's good. Control C, come here and put it. Now this key and this key is within the text, but enter is not there, so I'm gonna go for the black remote key and put this label instead of enter, OK, which I have to this is black with PCB. You see here black remote key, this is top, left, right, and then this is OK. I'm gonna change it to enter. That is done. Now we set our values here for the right, for the left, and then for the center, enter. So when this matches the list that we had there, then it will work. Now let's upload it. Just let's try it. So as you can see, it goes 10 degrees to the right. And it reached 0 degrees. Now if I want to go to the left, it will work the same way. And if I want to reset it or press it, let's go fully to the left, and enter will bring it back to center. As you can see, it's rotating, and enter will bring it to center. Thank you for watching. This was the video explaining how to use remote control with Arduino, or maybe your home remote control to control a servo motor. Please make sure to subscribe by clicking at the subscribe button in here. Thank you. Thank you for watching the tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos.